So sometimes we have to find the distance of things that we can't go outside and measure, or maybe we drew it up to try to get kind of that plan. So I wanted to take a moment and kind of go through an example or two on how can I find the distance if these items are sitting on the graph paper. All right, so we're going to take a look. So here I have this little garden that I want to build. Okay, but I couldn't really go a straight line here because there was a tree in the way. And then I have this giant puddle of water that never seems to like go away. And then I have this big old rock here. So I have this funky shaped garden. And I want to find out how much material I need to actually build it, to fill it, plus do everything else with it. So we're going to go ahead and take a look because I want to know, well, what is the measurements of these? All right. So in order to do this, we need to count the squares. So you're going to see here, this top line falls directly on a line. So I can just count and I could say, well, that's 1, that's 2, that's 3, 4, 5, that's 6 units from dot to dot. So I'm going to go ahead and write 6 units. That one's pretty easy, pretty straightforward because I can just count the squares. But it's not so easy when I'm looking at these other ones. So here, a lot of times we kind of like to go, well, that's kind of part of a square and a little bit more. And that's not how this works. Okay, so we need to use the Pythagorean theorem to find these distances. So fortunately, on a grid line, I can go ahead. So again, I'm going to be focusing here on this line. I'm going to connect this dot vertically up and then 1 over. Now I could have drew it to the outside of the shape too, but my tree is in the way. So we're going to go inside of the shape. All right, so notice I just made myself a little right triangle. And this top number here is one of the legs, so I have the number 1. And this side here is my other leg, and I have 1, 2, 3, 4, 5 units. So now I'm going to use the Pythagorean theorem to find out what that total length is. So I have a squared plus b squared equals c squared. And then I'm going to throw in here my handy dandy calculator. So I have 1 squared plus 5, my plus sign didn't want to go, plus 5 squared equals, and that's going to equal 26. Now I can't leave my answer like that. When c is squared, I get 26. Okay, would this length make sense to be 26 if this piece was only 6? That doesn't make sense. So I would have to then take the square root of 26, and I would find out that that length is just over 5 units. So I'm going to say it's 5.1 units. All right, so I'm going to change my pen. All right, so this area right here, this distance, is approximately 5.1. Okay, and we did the Pythagorean theorem with that. So I'm going to do that now with the other side length as well. All right, we're going to change up some colors here. So I'm going to play connect the triangle. So we're going to go here and then up. So notice again, I made my right triangle. So the distance I'm looking for is that hypotenuse. So I have 1, 2, 3, 4, 5, 6, 7 as one leg. I have 1 as my other leg. So 7 squared makes 49. 1 squared makes 1. So we get 50 is when c is squared. So now I got to take the square root of that answer. So we're going to go second x squared, 50. So this length here is approximately 7.1. So again, it doesn't make sense to be 50. Right? We need everything to kind of make sense in what it's doing. And what we just found out is not any of the lengths of the red. We found out the length of this purple piece. So this is 4.1, or I'm sorry, 7.1. Do what I write, not what I say. All right, and then let's find out this last unit here. We'll change it to one more color. How about we use this little pink guy here. All right, so again, I need to go from dot to dot. So I'm going to go into my rock. We're going to go straight up. Notice I'm tracing the grid line, and I'm following directly over, tracing this grid line. So here I have my right angle, which means I'm solving for hypotenuse. So we have 1, 2 units. So that means I'm dealing with a square root of 2. I have 1, 2, 3, 4. I'm not going down here. Don't let your work deceive you. I have to go to the point. 1, 2, 3, 4 units here. And now we're going to solve. So 2 squared, oops, sorry. So 2 squared is 4, because that's 2 times 2. 4 squared is 16, because it's 4 times 4. And so we get 20 equals c squared. And again, 20 doesn't make sense as an answer. So I have to take the square root of 20, square root of 20, and I find out that side length is 4.5, 4.5. And again, when I'm going to my illustration, that's representing the purple part. This purple line is 4.5. Okay, so we have top part is 6. We have this side of 5.1. We have this bottom of 7.1. And we have the side of 4.5. So I would then take my calculator because it's asking me, oh, well, how much material do I need to build this border? So that means I'm finding the perimeter. 6 plus 5.1 plus 7.1 plus 4.5 equals. So my total material that I would need is 22.7 units, but I'd probably go to the store and buy 23. Hopefully this helps. Enjoy your assignment.